So here we want to estimate this limit. So a calculator is a great way to do that. So, and then we'll see if we can apply some algebra, like often with rational functions we can. So we've seen that in a few examples where rational functions, we were able to not just estimate, but exactly find the limit. So first thing is a calculator. Let's try Desmos again. It's been very handy lately. Uh-oh, and my computer does not want to do so. I had this problem the other day too at the end of class. All right, so let's do this. Oh, it's my Zoom. Ruh-roh. Okay, so I can't get back to my calculator, so we're going to do this oh wait, I have another idea. What if I try this? No. Okay, so Zoom is malfunctioning on me. Can anybody see my screen right now? And let's see, I cannot access chat or your pictures. Somebody needs to give me a voice. Tell me if you can see my whiteboard.
Yeah, I can see it.
Okay, so somehow Zoom is not letting me share my screen. It's only letting me share my whiteboard. So I'm just going to have to do this without a calculator. So the hope is that x minus 6 divides into this here, and I can get rid of the problem. Right now, if I plug in 6 into the numerator, my guess is I'm going to get a 0. And I can clearly see there's a 0 in the bottom, right? So x equals 6 is a problem. So x equals 6, 6 implies we're going to get a denominator of 0. And if we plug it into the numerator, my guess is we're going to get 0 there too. So we're going to have a 0 over 0 situation. So what I'm going to do is I'm just going to try division. Now, since this is just simply x minus 6, I could use synthetic division. I'm going to do long division on this. So I want to take x minus 6 into x cubed minus 4x squared minus 7x minus 30. So this is a good skill. You're going to need this later in the course. So what would I multiply by x to get x cubed? And the answer is I would multiply an x squared. X squared times x is x cubed. X squared times negative 6 is negative 6x squared. And then we subtract by adding the opposite. So I'm just going to change each of these signs. X cubed minus x cubed, that should always be a 0 first, so that's gone. And then negative 4x's plus 6x squared is going to give me 2x squareds. Bring down the next term. What would I multiply by x to get 2x squared? I would multiply by a positive 2x. 2x times x is 2x squared. 2x times negative 6 is negative 12x. And then we subtract by adding the opposite. So go through and change the signs. Negative 7 plus 12 on a good day is what, 5 x's minus 30. Bring that down. What would I multiply by x to get 5x? I would do a plus 5. 5 times x minus 6 is 5x minus 30. Subtract by adding the opposite. So change those signs, and I do get a 0 remainder. So x minus 6 is a factor. So this is equal to the limit as x approaches 6 of x squared plus 2x plus 5. So what that means is if you graph this sucker right here, it's going to look like this parabola. And it's going to actually be equal at every single point except where x equals 6. This function here has a hole in the graph. Oops, wrong spelling of hole. This has a hole at x equals 6. Whereas this function right here, you can actually plug in 6 and get an answer. 6 squared plus 2 times 6 plus 5 is what? 36 plus 12 plus 5, which is 40, 53, if I did that right. Yep. So we should find that this limit right here is 53. But the point 653 does not exist on this graph. It's a hole in the graph. But the limit is 53. Oh, okay, Zoom is behaving again. All right, let's stop that.